Hello students. In a previous lecture, we have derived the expression for your electromagnetic torque in an induction machine. So this was the expression which we have derived in your previous lecture. Now I've told you that you can see from this expression. Today we'll be basically obtaining your torque slip characteristics, and I'll be explaining you the various concepts involved in your torque slip characteristics. Okay, you can see one thing that in this expression TE, electromagnetic torque, is equals to thrice of ETH whole square, and in this expression you can see that TE is dependent on only slip. Why? Because once your machine is provided with some source V1, if the source voltage is kept constant, and obviously the resistance, the stator resistance and the rotor resistance and the leakage reactance, means the stator impedance and rotor impedance are kept constant. Since once the machine is designed, it is kept constant, then you can see your electromagnetic torque developed is a function of the slip of the machine, which is changing, which is continuously changing with time. So this thing is very important. So now we need to develop a characteristics. We need to plot a characteristics between the torque and the slip. So you can see here we can substitute different values of slip, and we need to find out the values of torque. So what we have done is, suppose value of slip is 0, then you can see that the value of the torque obtained is will also be, the electromagnetic torque obtained will also be 0. You can see from this expression also, take r2 dash by s common. So here you'll get r2 dash by x ka whole square, and then this r2 dash by s and this r2 dash by s will get cancelled out, and there'll be one r2 dash by s over here, and then s goes upwards and substitute s equals to 0, so torque equals to 0. You can do it on your own from this thing. Okay, fine. For s equals to 0, torque equals to 0. And obviously you also know one thing, that whenever s equals to 0, what does it signifies? S equals to 0 means your rotor speed is now equal to your synchronous speed. So nr is equals to ns, or when this thing happens, then there is no relative speed between the synchronous speed and the rotor speed, and hence your induced emf will be 0, and hence your current will be 0, and hence your electromagnetic torque will be 0. Okay, so you can also see I've written these things. You can also see from the concept also, when slip equals to 0, torque equals to 0. Okay, see that this is how you need to correlate all the different things. Then only you'll be able to understand it in a much better way, much nicer way. Because this is the thing that you need to follow. You need to always think, why is it happening, how is it happening. These things you should be thinking, and you should be questioning yourself each and every time. Means this is how you get to learn some subject. Okay, otherwise there's no point in deriving all those things. Okay, you need to feel it. Okay, so without wasting much time, as our video duration could not be much longer, so now you can see that for different values of slip, for s equals to 0, you got torque equals to 0. Similarly, for s equals to 0.01, you will get some values of torque, and then for s equals to 1 over and so on, you will get the values of torque. And then when we plot these things, you get a characteristics like this. This is known as your torque slip characteristics. This y-axis represents your electromagnetic torque, and your x-axis represents your slip. Now see, at starting, and see, this slip is equals to 0, and we know that when slip is equals to 0, torque is equals to also 0. And here the slip is equals to 1, s equals to 1, and s equals to 1 represents what? Your starting condition, your standstill condition, means your rotor is stationary. That situation is represented by s equals to 1. So rotor is stationary, means rotor is not rotating, means nr equals to 0. Okay, and s equals to 0 represents what? When the speed of your rotor is equal to your synchronous speed, that is when nr is equals to ns, then only s equals to s will be equal to 0 na? Because what is s? Slip is nothing but nr minus ns minus nr divided by ns. So when nr equals to ns, then slip will be equal to 0. So you can see, as we move from left to right, okay, from left to right, your slip increases from 0 to 1, and as we move from right to left, your speed increases from 0 to ns. So obviously you know that speed and slip are inversely proportional. As your slip increases, obviously your speed will decrease. Okay, now one thing more, Now this is at s equals to 1 means at starting when your rotor is stationary, this electromagnetic torque which you are obtaining is known as starting torque, starting electromagnetic torque, because here the slip is equals to 1. Rotor has not yet started rotating. Okay, rotor is yet stationary. So this torque is known as your starting torque. Okay, keep this in mind. And then we'll go this way, this way, this way, and this is the maximum torque your in this induction motor can develop. Okay, and the slip corresponding to this is s equals to alpha. Say, let's say s equals to alpha. This is the slip corresponding to maximum electromagnetic torque. Means whenever the slip is this, whenever the in any induction machine, say suppose there is one induction machine whose torque slip characteristics is given by this thing, then whenever the slip is equals to alpha, then you will get the maximum torque. Okay, and this is your working region. We'll show how this is your working region. Here your basically your induction motor operates. Okay, I'll show you how. This thing is should be very careful. Okay, this thing is your starting torque. Okay, now see, we'll read these things. What does it says? That for a well-designed induction motor, the value of the slip at which machine is capable to develop maximum torque is approximately zero point 0.1. What are they trying to say is that for a well-designed induction motor, usually what they do is that the value of the slip for which maximum torque occurs, means this s equals to alpha for which maximum torque occurs, is usually zero point 0.1. What does it signify? That is s for t max is usually 0.1. 0.1 or less than 0.1, approximately it is taken as 0.1 or 10%. Slip is 10% of the maximum value. Maximum value is s equals to 1, so it is around 10% of the maximum value. Beyond this thing, usually we do not go. Means this is that's why they say that this is the region for operating of an induction machine. This thing from years from torque equals to 0 to torque equals to maximum. This is the reason for an operation of induction motor. And in this region, the value of the slip changes very slightly. You can see from 0 to 0.1 only. So very slight, very small change in the slip. Okay. See, we'll further. I'll discuss further upon it as we go on, as we move on with the various aspects. So this is what is written. Now the starting torque of the induction motor must overtake the opposing torque T friction, then only machine will accelerate. What does this signifies? I'll tell you one thing. Wait, Anna. Okay, I'll tell you over here only. See, we know that for any induction motor and any induction machine, I've already told you in your previous lecture that for a machine to rotate, in every machine there are two torques. See this thing. One is your electromagnetic torque, another one is your opposing torque. If your machine is operating on no load, then the only opposing torque available is your frictional torque. Okay, when your machine is operating on no load, then only opposing torque that is available is your frictional torque. Okay, keep this in mind. Now for a machine to rotate in clockwise direction, I've told you this electromagnetic torque should be greater than this thing, opposing torque. Then only your machine will accelerate. Whenever this electromagnetic torque is less than this opposing torque, then your machine will de-accelerate. Okay, are you getting my point? Then it will de-accelerate. So if a machine is say at standstill, if a machine is at stationary, your machine rotor is stationary, then if your opposing torque is greater than this electromagnetic torque developed at standstill condition, then obviously the machine will not rotate. Why? Because your opposing torque is greater than this. So in order to rotate your machine, your electromagnetic torque developed at starting must be greater than your opposing torque. Then only your machine will rotate in clockwise direction. In this case, let's say. Are you getting the point? So this is what is telling. Is telling you that this starting torque, electromagnetic torque developed at starting when your rotor was stationary, this starting torque must be greater than the frictional torque. Suppose the machine is operating at no load, then this starting torque must be greater than the frictional torque, the friction that is provided by the shaft itself. So it must be greater than the frictional torque. Then only your machine will accelerate. Are you getting my point? Then only machine will accelerate. Otherwise, machine will not accelerate. Okay. Okay. Now they're also telling you one thing, that at what At what slip TE maximum occurs and what is the value of TE maximum? This is the derivation. This we know that as s equals to alpha, we get TE maximum. So they're just wanting you to find out this, what is the value of this alpha, what is the value of the slip s equals to alpha when maximum torque occurs, and what is the condition for that. So at what slip T maximum occurs and what is the value of T maximum. So we know that the expression for T is nothing but this thing we have derived previously. So all things are constant except s. So if we I'm sorry, sorry. We have directly come to the, I don't know which slide. Okay, now here this thing we were discussing. So we know that in order to, when if you want to develop any torque, then what are the conditions for that? Suppose I need to develop the maximum torque. Whenever you need to find out what is the maximum value, then you need to differentiate it with respect to the changing parameter. This is the only changing parameter, this is not constant. So we'll differentiate this torque with respect to s and put it to 0. Now whatever value of s you will get, you can substitute that value of s in this expression in order to get this maximum torque. This is what we used to do in your mathematics. Okay, so now this is what we can do, but there is one more very short method. Since we are an electrical engineer, we know one other thing. We know something else other than this method. This was your mathematical method, and it would be very tedious job to do. You can do it by this thing also. This you may take it as an assignment and you can do it by this thing also. You'll find that they both, by both the things, the expression will come one and the same thing. Why? Because you know this is your mathematical proof. So you can obviously anytime you can do these things. But if you want to since you already studied your circuit analysis and you have already studied various theorems like maximum power transfer theorem, so you now there's need to apply that theorem in order to find out what the your maximum torque. How? See, this was your equivalent circuit which we have developed, Thevenin's equivalent circuit, VTH, RTH, XTH. This was your rotor structure, X2 dash, and then R2 dash divided by S. Power in this resistance is PAG. We know that this power in this resistance R2 dash by S is nothing but PAG, air gap power. And also we know that this air gap power PAG is also a measurement of your torque. I've told you that whenever you are measuring your torque in synchronous watt, then torque is directly the measurement of your electromagnetic torque. Here, I'll tell you again. I'll take you back. This thing. See, this electromagnetic torque is equals to your PAG, that is air gap power, in synchronous watt. Okay. So if you you can derive one thing. You can conclude one thing that in order to find maximum torque, if this PAG is maximum, then obviously this torque will also be maximum. Okay, are you getting the point? So what are we going to do is that in this thing, instead of deriving this thing, instead of doing all this mathematical calculation, what are we going to do is that we'll use maximum power transfer theorem. We know that the power in this resistance, in this R2 dash by S, is nothing but your air gap power. And also we know one more thing, that this air gap power is also a measurement of your electromagnetic torque. So what are we going to do is that now we'll apply basically a maximum power transfer theorem. What does it says? That the value of the load resistance, in order to get maximum power from the source, in order to extract maximum power from the source, the value of this load resistance must be equal to the the magnitude of this resistance, magnitude of this impedance. This is what your maximum power transfer theorem. This R, this load resistance, let us suppose this is RL. Suppose this RL must be equal to root of RTH plus root of RTH plus XTH plus X2 dash whole square. So this magnitude, this load resistance must be equal to the magnitude of this thing. This is what is said by your maximum power transfer theorem. So now we are going to apply that thing only. See, you can see torque will be maximum when PAG maximum. So apply maximum power transfer theorem. At what slip power is maximum in R2 dash by S will also give maximum TE. So When we apply maximum power transfer theorem, that means this R2 dash by S must be equal to root of RTH ka whole square plus XTH plus X2 dash ka whole square. Are you getting the point? So this is how we have obtained we've used the maximum power transfer theorem. And you can see one more thing, that now this slip, the value of this slip is the slip of maximum torque. Okay, whenever this condition satisfies, then you will be getting the maximum torque. We have obtained maximum, we have used maximum power transfer theorem to obtain this thing. Okay, slip at which maximum torque occurs will be equal to S. You can replace S with alpha. Alpha is equal to nothing but R2 dash divided by, you can bring this to denominator, root of RTH whole square plus XTH plus X2 dash ka whole square. So are you getting this point? Now once you have developed the slip at which maximum torque occurs, you can substitute the value, since this is your expression for your electromagnetic torque. Now if you want to find out what is the exact value of the maximum torque, then you can, what you need to do is that just substitute the value of slip over here by this value alpha. So you need to substitute this value by this value. So what basically you do is that you could substitute this thing R2 dash by S. You know that for maximum power transfer theorem, R2 dash by S should be equals to this much. So you can replace this R2 dash by S with this expression, root of RTH ka whole square plus XTH plus X2 dash ka whole square, both here. So in this expression, this will also be replaced and this will also be replaced. So whatever you put this R2 dash by equals to this, so what are you going to get? You will get this type of expression, replacing R2 dash by this. Again, this R2 dash by S is also replaced by this thing. Now what you need to do is that you need to open this square. This is square na? So when you open this thing, this will give you RTH ka whole square plus this root will disappear, plus twice of this RTH into this thing, okay, plus this thing. So you can and when this root will disappear, you know that this will also give you RTH ka whole square, and RTH ka whole square was there also. So RTH ka whole square plus RTH ka whole square, you'll get twice of RTH ka whole square, and this plus this will give you twice of XTH plus X2 dash plus twice of this. From here you can take this thing as common, so this and this will cancel out, and then you'll get this thing, and finally you'll obtain the expression for your maximum torque. Are you getting my point? So this is your expression for your maximum torque. Now we will be continuing from this point of from here only in the next lecture. Thank you, and I'll request you to request you all to kindly go back through all this derivation and understand it. And do it by practice. You can practice it and use this. You can go and revise your maximum power transfer theorem also, and this is how will basically help you out with this thing. Okay, thank you very much.